Ever wondered what computers looked like before sleek apps and user-friendly interfaces? Picture a room full of machines only speaking in ones and zeros. Now imagine being the translator between those machines and humans. Sounds intense, right? That's where assembly language came in, bridging the gap between human logic and machine code. Stick around to discover how assembly became the foundation of early computing and why it's still legendary today. Before you could open your favorite apps with the click of a button, computers were giant, room-sized machines that only understood one thing: binary. Programmers had to tell these machines exactly what to do using ones and zeros. And let me tell you, it wasn't exactly user-friendly. Enter assembly language, a tool that changed the game for early programmers. It allowed humans to give instructions to computers in a way that made sense, without needing to memorize endless strings of binary. Back in the 1940s, computers like the ENIAC could only be programmed directly in machine language, which was, well, literally a bunch of ones and zeros. This made programming slow, error-prone, and incredibly complex. But then assembly language came along to simplify things. Instead of writing long binary sequences, assembly allowed you to use easy-to-remember words, known as mnemonics. You could now tell the computer things like, move this value, or add these numbers using short, readable instructions. This was revolutionary. So, how did assembly language help power these early machines? Well, it was the stepping stone between raw machine code and more human-friendly languages that would come later. For the first time, programmers could give instructions in a way that made sense to them while still being precise enough for the computer to understand. For example, on early computers like the UNIVAC, assembly was used to handle everything from calculations to data storage. It allowed programmers to control the hardware directly while avoiding the nightmare of typing endless binary code. Can you imagine running an entire weather simulation in binary? With assembly, it was still tough, but at least you didn't need a photographic memory to get the job done. But here's where things get really interesting. Assembly wasn't just a tool for the early machines. It became the blueprint for every programming language that came after. In the 1970s, languages like C started to emerge, offering more complex instructions, but still following the same logic as assembly. C was actually built on top of assembly language concepts, allowing developers to write faster and more portable code. Even modern languages like Python still have deep roots in assembly. Assembly is like the grandparent of all modern languages. Its influence is everywhere, from the low-level operations that handle your CPU to the inner workings of your favorite apps. You might be wondering, with all these fancy, high-level languages today, does anyone still use assembly? The answer might surprise you. Even in today's world, assembly is alive and well, especially in systems where speed and efficiency are critical. It's still the go-to language for embedded systems, like those in your car, your microwave, or even the space probes sent to other planets. Anytime you need to squeeze every ounce of performance out of hardware, assembly is there. It allows programmers to write incredibly efficient code that takes full advantage of a machine's power, making it crucial for industries like aerospace, robotics, and even gaming. Who knew that the same language that ran early computers is now helping power cutting-edge gaming consoles and space exploration? Now let's dive into some famous moments where assembly made history. One of the coolest examples of assembly in action was during the Apollo moon missions. The Apollo guidance computer, which helped land humans on the moon, was programmed almost entirely in assembly. The code was so efficient, it ran on just 64 kilobytes of memory. And let's not forget about early video games. Games like Space Invaders and Pac-Man were all built using assembly. Developers needed to optimize every line of code to make sure the games ran smoothly on limited hardware, and assembly allowed them to do just that. So, why does assembly's story still matter today? It's not just because it was the language that powered the first computers. It's because assembly taught us the importance of understanding the inner workings of machines. It showed us how to communicate directly with hardware, laying the groundwork for everything we use today. And while most of us won't write assembly every day, its influence is still everywhere, in every program, every app, and every device. Assembly might be small, but its legacy is massive. Thanks for joining me on this trip through computing history. If you enjoyed this journey into the world of assembly language, make sure to like, subscribe, and leave a comment below. Let me know what other programming legends you'd like to hear about next. Until then, happy coding!